Hello Year 10. Today we're going to be learning about linear inequalities, but let's do a few quick revision questions first. So question 1, we want to solve an equation which involves brackets, so let's expand those brackets out. 2 times 3x makes 6x. 2 times minus 2 is minus 4. Then minus 3 times x is minus 3x. Minus 3 times 1 is minus 3, and that's equal to 5. Let's collect up like terms on the left-hand side of that equation. 6 take away 3x is 3x. Minus 4 minus 3 is minus 7 equals 5. Then, solving by doing opposites, we're going to add 7 to get 3x equals 12, and then divide the 3 to get x equals 4. In question 2, to solve the equation, normally I would like to collect up the pronumerals that I have on both sides, but I can't do that while the 5 on the bottom of this fraction here is in the way. So I'm going to multiply the 5 over to the other side. That would give the x plus 2 from the top, and the 5 is multiplying over to the 2 minus x. I have to put in brackets because everything there has to be multiplied by 5. Then I can expand out the brackets. 5 times 2 is 10, and 5 times x is 5x. Now I can finally take this 5x here, which is negative. I'm going to add 5x so that I can collect up the x terms. X plus 5x makes 6x plus 2 equals 10. Okay, then we're going to subtract 2. We get 6x equals 8. And then finally divide the 6. 8 divided by 6 is 4 over 3, or 1 1/3. And the last question, it says make A the subject of the equation. So I want to get the A here by itself, which is a bit of a problem because there's 2 fractions in here and the A is on the bottom of the fraction, so it could potentially be a bit messy here. But the first thing I would do is to take this whole second term here and move it across to the other side of the equation. That would look like this. You'd have 1 over A equals, when you move that term across, it would become a negative 1 over B, subtracting that whole term across to the other side. Then, what I've done by doing that is I have a fraction on each side of my equal sign, which means I can cross multiply. So I do 1 times the B would be B, and negative 1 times A would be negative A. Or, if I want the A by itself, all I do is divide by negative 1 to move the minus over to the other side, and it would be A is equal to negative B. So those are questions. Some of them are a bit tricky, but that's what we've been doing in the previous lesson. So if you're struggling with that, you may need a bit of extra practice in there. But let's move on to our new work, which is on linear inequalities. So inequalities are the less than and greater than symbols. So the first symbol here, this is a less than symbol. This is greater than, less than or equal to, greater than or equal to. So the extra line on those bottom 2 mean that they can be equal to that particular number as well. So if you are trying to solve an inequality, please remember that if you divide or multiply an inequality by a negative number, you must always reverse the inequality sign. That's the main thing you need to remember. Otherwise, a lot of the steps that we do are pretty much like solving normal equations. You may also be asked to represent an inequality on a number line. So there's a few of them here to look at. So this first one, x is greater than A. And these other symbols here, let me just fix these ones up. That one there should be a less than or equal to. Okay, so we have two different types of dots. If you have a greater than or a less than symbol, so the ones that do not have equal signs, we use an open dot to mean that it can't actually be at that number, it can't actually be at A, but it's all the way up to it, so it's all around it, but not at the A, so open circle. Whereas if we have the ones that have equal signs on them, then we use coloured in dots to say, yes, it can be right at that point. So, x is greater than A is an open circle at A, and it's pointing to the values that are greater than or bigger than. Okay, one way to remember that is that the direction of your inequality, so that arrow, the inequality is pointing that way, so this arrow is pointing that way. If it has an equal to sign on it, the only thing that changes there is that this is now a coloured in dot, but still pointing that way. Once it is a less than sign, which means pointing to the left, that means this arrow is pointing to the left, open circle because it didn't have an inequality sign. Whereas when it had the inequality sign, we coloured in the circle. On the next page here, we have some that are between two numbers. Again, don't worry about these pound symbols, just likes to convert some of my symbols wrong. So, if the first one that we have here, this is a... The first one that we have here is A is less than X is less than B. That's how people often try to read those the first time they see them. But when I read it, or the way I would encourage you to read it, is this is saying that X is between A and B. All of these ones that you see here, you'll see that the symbol is always a less than symbol. Okay, the X is in between, so that means the number, the value that is over here on the left-hand side will be the lower end of your numbers, and the one that's on the right-hand side will be the upper end, and the X is in between. So again, because there's no inequality, equal sign on these inequalities, they're going to be open circles at the A and the B, and it's putting a line to indicate anything between the A and the B. Once you put the equals to signs on them, all we're doing is colouring in the dots. You could put a non-equal sign on the first one and an equal sign on the second one. That means that A will be an open circle and B will be a coloured in circle. And the last one is reversed. So A is less than or equal to, so it has the coloured in circle on A, but there's no equal sign on the B, so an open circle at the B. So first of all, let's practice. Here is some pictures. Can we write down the inequality that would represent those pictures? So the first one, I have an open circle at 1, and it's pointing to the numbers bigger than 1. So X here is the pronumeral that we're going to use. X is bigger than, but not equal to, the 1. Whereas in part B, because we're between two numbers, we're going to have the X in the middle, and we're going to have two less than symbols, but the one at -2 will be a less than symbol, but the 3, because it has a coloured in circle, we're going to put the equal sign on that, and then there. So that means X is between -2 and 3. Okay, so continuing from there, we have to, in question 2, we have to solve the inequality, and then we have to sketch the solution on a number line. So in A, we have X plus 5 is less than 9. So remember, if you multiply or divide by a negative, then you have to turn the sign around. The other thing to look out for is if your pronumeral is on the right-hand side of the equation. If you switch sides, then you also have to turn the sign around. But otherwise, like a normal equation. So let's -5 minus 5, and we have X is less than 9 take away 5 is 4. So it's solved. Then to draw it, we just roughly draw a line here. 4 is our number, There's no equal sign on it, so an open circle and less than points to the left. And we're done. Oh, technically it's an x, so we should put an x there on the line. Moving on to B. Solving it first, we're going to add the 3, so we get 4a is greater than 22. Then we are going to divide the 4. So a is greater than or equal to 22 divided by 4 is 5.5. So drawing on a number line, put the 5.5 somewhere in the middle there. This one has an equal sign, so coloured in dot and pointing to the ones bigger. And this time it's an A solution, so we put an A on the end. Question C, solving the inequality, we're going to subtract the 5 because the minus sign belongs with the A. So that will be negative A is greater than 9 take away 5, which is 4. To get rid of the minus in front of the A, we're dividing by a -1, which means dividing by a negative, we turn the sign around. 4 divided by -1 is -4. So -4 in the middle, open circle, pointing to the left. Question D, solving the equation, we're going to get rid of the 3 from the front, so -3. We have minus x over 5 is less than or equal to 6 minus 3 is 3. Now, the minus that is here at the front, it can belong with the x or it can belong with the -5. If you want to finish this in one step, put the minus with the 5 and say, I'm going to times by -5. And so you can get rid of both of them at the same time. But when you multiply by a negative, you must turn the sign around. 3 times -5 is -15. So drawing it, -15 is there, coloured in circle, pointing to the right. And that should be an X. Okay, E. Getting a little bit more complicated as we go down. This time we have some brackets, so let's expand them. So 7 minus 5m is greater than -2 times 3m will be -6m, -2 times -1 is +2. Now let's add the 6m to both sides to get the pronumerals all over on the left. So we have 7 minus 5 plus 6 will be a +1 or plus m is greater than 2. Then minus the 7 and we get m is greater than -5. Drawing that, this is m, we have -5 for our solution, open circle and larger than, pointing to the right. Question F, 2 fractions there on the same side. So if I want to get rid of those fractions in one go, I could multiply the whole equation through by the lowest common denominator, which would be 8. So let's multiply this equation, this one here by 8. I'm going to multiply this one by 8. I'm going to multiply this one by 8. Each term multiplied by 8. Now the first one, 8 divided by 4 is 2, so that becomes a 2x. The second one, the 8 will cancel that 8, so that becomes a -5x. And then is less than -2 times 8 is -16, and the fractions are all gone. Also, we have 2 x's on the left-hand side that we can collect up. 2 minus 5x is -3x is less than -16. We divide by -3, which means turn the sign around. -16 divided by -3, the 2 minuses cancel out, and that's 5 1/3. So 5 1/3, open circle, pointing bigger, and there it is. Couple more questions to go. Question 3. The sum of 2 consecutive even integers, of which the smaller number is x, is no more than 24. We've done questions like this with normal equations, but this is an inequality. The no more than means it's not equal to, and we'll talk about what symbol that is when we get to it. Let's see if we can build the first part first. The sum means I'm going to be adding some things. Two consecutive even integers. Now, consecutive means numbers that are straight after each other. So the numbers 3 and 4, they're consecutive numbers because 3, 4 follows that. If we were talking about algebra, if x was the first number, the next number would be x plus 1. But if they both had to be even, I would have to skip the odd numbers. So if my first number is x, my second number would have to be x plus 2 because I'm going straight from, say I was doing the even numbers of 6 and 8. So I don't want 6 and 7 because I'd have an odd number in there. I wanted to have 6, skip the 7 and go all the way on to 8, which is why I'm adding 2 on instead of 1. So these are my two terms, if you like, and I want to add them together because it told me to sum them. And then it says the sum of the two consecutive integers of which x is smaller, okay, so x is the smaller number, I added 2 on to get the bigger one, is no more than. So this, at the very, very most, can be 24. But that means it could be less than or equal to. So it could be 24 or it could be less than 24. So no more, that's what no more than means. Could be 24, but it could also be less than that. Now to solve that, x plus x makes 2x plus 2 is less than or equal to 24. Minus the 2 away, 2x is less than or equal to 22. Divide the 2 and we get x is less than or equal to 11. Okay, now, with a wordy question like this, you always want to make sure your solution is valid. The question said the sum of two consecutive even integers. Is 11 even? No. 11 is an odd number. So while 11 and 13, if I added 2 on, 13 would be my other number. They do add to give 24, but neither of them are even numbers. So the first number that's going to work for me would actually be 10. So I would write a little statement here. I would say, since x must be even, I'm actually going to have to drop my answer down to be x is less than or equal to 10, which means 10 and 12, which makes a total of 22, would be my first set of numbers that would actually work for that. Because in my original equation, I had no way of knowing whether I was actually finding even numbers or odd numbers. So I had to make sure I write that in my little conclusion there. Question 4. Solve 7 is less than or equal to 7x minus 70 is less than or equal to 14. And sketch the solution on a number line. Let's give this one a star. Okay, so we are solving an equation that has two inequality symbols in it. Now, the best way to solve this is to think that there's 3 parts here, and as long as I do the same thing to each part of that equation to keep it balanced, then I can solve it. So if I'm trying to find out what x is equal to, I want to get rid of the 70 and the 7. So the first thing I'll do is add 70 to the 3 different parts of that inequality. 7 plus 70 is 77, is less than or equal to, those ones will cancel out, so 7x, and 14 plus 70 is 84. Now to get rid of this 7 here, I'm going to divide by 7, divide by 7, divide by 7, all 3 parts. 77 divided by 7 is 11, less than or equal to. These 7s cancel out, so that's my x. 84 divided by 7 is 12. So solving that, my solution is that x is between 11 and 12. And if I draw that on a number line, as I was asked to do, there's 11, There's 12. They both have equal to signs on them, so they're going to be coloured in dots, and it's going to be anything between, so it could be any decimal number in between 11 and 12. All right, your turn now to do exercise 1C.